Hey guys, welcome back to the checkers tutorial. In this one, we actually implement some conditions when we do the move. So the white team, they can't go left, they can't go right, they can only go in diagonal. Well, like the other team as well, but as you can tell, they can't go back to where they were, so they only have one direction. There's still a lot of bugs going on, but at least we're getting rid of them one by one. And eventually we'll have something clean that works super well. Anyway guys, without further ado, let's get right into it. Alright, so in this episode, we're going to be moving our pieces depending on exactly where they can go. So we're going to be restricting where they can go, because right now, move piece is just going to take you wherever you stop dragging your object. But it's going to be a little bit different in that. Let's start by checking if they're out of bounds. That's the easiest thing we can do. So if x2 is smaller than 0, or x2 is bigger or equal than 8, or if you prefer, just pieces.length. Let's do another OR statement, same thing for y. So if y2 is smaller than 0, if y2 is bigger or equal than pieces.length, then we need to actually, right here, we must not do a return, because we need to delete few things we have. We have to remove the selected pieces. So selected pieces has to be null. The start drag has to be null as well. So let's do start drag is equal to vector 2.0. We're just resetting that to where it should be. If there's no value, then we do a return. And something else I'd like to do, actually, you know what, before we even get into making the try move, what I'd like to do is move my selected piece with my cursor. That could be something I'd like to do first. Okay, sorry about that, just jumping from one end to the other, but this one is going to be quite cool to look at. So what we're going to do is we're going to create a new function that just updates the position of our piece if we have one selected. Let's call this private void update piece drag or something like that, and send as parameter the actual piece itself. Now all we really have to do here is get the information that we had when we did our raycast, which I feel like just doing again. So let's just quickly do that again. Going to be copying this over the whole function in mouse over, going to copy this inside of update piece drag. Let's keep this part, and let's also keep the raycast. Okay, that's all we really need at this point. And if we do manage to hit something, then let's do p.transform.position is equal to hit point, and we'll do vector3.up. So when we're actually selecting a piece, it's going to be elevated on the board. It's not going to be on the same level, so it doesn't enter collision with the other pieces. Well, they don't really have collision, but at least you don't see them overlapping in the game. Let's take our update piece drag function and put it inside of, say, here. So if it's my turn, let's go ahead and try to move a piece if we do have one. So if selected pieces is not equal to null, update piece drag with the selected piece. Okay, with this little line here, we should be able to see something quite great happening in our game. Press here. As you can tell, we now have a piece. And that's fairly cool. Okay, let's go back to our function here, the try move. Sorry about just jumping from one function to another. But I was just thinking that about here, if you're out of bounds but you're dropping your click, you should also drop that selected piece. You should actually return it back to where it was. And this is how I do it. So if selected piece is not equal to null, again we do the simple check. If it's not equal to null, let's do a move piece, moving the selected piece, and the place we want to move it back is where it was at the beginning. So start drag in this case. And then we just cancel the move. As simple as that. Oh, but right, move piece actually takes in a x and a y, not a vector 2. So we have x1 and actually y1. This is the start position. Alright, so if we're out of bounds, we're just canceling our move. And by canceling, I mean we just put the piece where it should be. We have it in our hands and we're just dropping it somewhere that doesn't work. So if it actually happens, we're going to take that piece, put it back at where it should be, reset start drag, and also reset the selected piece. And this is something we should do every time the move is not allowed. Right now we only checks for out of bounds. But then let's actually go a little bit deeper. So let's first check, is there an actual selected pieces? If there's none, then we don't do this. We're not gonna enter this if loop. Now, however, if we do have a selected pieces, if we do have like a piece in our hand, well, we're gonna do if the destination drag or the end drag is equal to the start drag, that means we haven't really moved. So let's go ahead and just cancel our move. And we're just gonna write something here if it has not moved. Well, if it didn't move, let's move the piece back to where it should actually be. So move piece, just like we did like a second ago, move piece, selected piece, x1 and y1. So if we're not having a valid move, we have to put it back to where it was. And for some reason, one of these is a vector 3, end drag is a vector 3. So a little mistake here on my part, it should be a vector 2. Okay, so as always, like I said, we're going to be doing this quite a lot here. Put it back, and if our move is cancelled, we do all of these four. Let's actually check if it's a valid move. So check if it's a valid move. And in here, there's going to be quite a lot of stuff to do, and what I feel like doing actually is just writing that in the piece class here. And the piece is going to be checking if it's allowed to move or not. I feel like doing that because else it's going to become like a real mess in here. It's already quite a big function, and I don't think we should go a little bit beyond that. So what we'll do is the if statement. So if selected piece, and he's going to check for his move, like is it valid? And if it's valid, then he's going to go ahead and just complete it. However, we don't have a function like that, so we'll just leave that here on standby, go in pieces, and start laying down a function to know if it's a valid move or not. So public bool, valid move, and what we'll take in is a reference to the board, or since it's actually like a two-dimensional array, you don't have to write that it's a reference, it's just simply going to give you one. So the board itself, also a position where we start, so int x1, int y1, and also the end position, so int x2, and also int y2. So quite a lot of stuff in here. We're checking if we're actually able to move or not. And something else we're going to need to know, because it's going to be different whether it's a black piece or white piece, is which color is it. So public bool is white. I'll call this like that. And there's also another one. Public bool is king or queen, depending on which kind of checkers you're playing. But when your checker is actually reaching the end of the board, it turns into a quotes king, and it can go in two directions. It can go like the black team or the white team. So it doesn't really matter at this point. We have to know these two things, and I'll put them public so I can have a look at them while I'm actually playing the game, and also because I'll be toggling this on from the checkerboards, most likely. Okay, so let's have a look at the valid move now. Let's simply check, are you moving on top of another piece? That's the first one we'll do. So if you are moving on top of another piece, that's illegal. You're not really able to do that. You know, you can't really stack pieces. So if board at the index, the destination, in this case that's x2, y2, is not equal to null, then we return false, because that's a invalid move. And then we'll do the movement for the white team. So if it's white or is king, so if white or king, we check how many tiles are you jumping in X. If you're jumping only one tile in X, that means you're just doing it like a normal move, right? If you're only jumping one tile in X, you're gonna be moving, you know, in diagonal top left or diagonal top right. Now, if you're moving two tiles in X, that means you're jumping on top of another piece, and at this point, it's gonna be like, you know, that's gonna be a kill, that's gonna be a jump. So we should actually keep track of how many tiles you're jumping. I'll call this delta move, and I'll do it above here. So int delta move is equal to matf.absolute, because you can be moving in two directions. So what I'll do is I'll just turn that into a positive. The x1 and then the x2. So x1 and x2 turn that into a absolute here, and we don't have to cast this as an int because I think it has an overload for that. So it's gonna give you how many tiles are you jumping in X, and if you're jumping one tile, it's a simple jump, and if you are jumping 2 tiles, it's a kill. Right. So let's do that. So if delta move is equal to 1, should be a normal jump. Else if delta move is equal to 2, that's a kill jump. So how do we go about checking this? Since we're in a white team, we have to go up. And we can just check the delta y. Are you moving we already know that you're moving at least 1 in x, so either left or right from where you are. Now are you moving 1 up? So we'll do the same exact thing as we did here, but that's going to be for the delta move in y, which I'll just put in here as well, why not? So in delta move y, y1, y2. Okay, we'll use this one inside of the function. So if delta move is equal to 1, we return true because that's a valid move. So you're not jumping on top of another tile, you're not jumping on top of another player, another piece. You're moving at least 1 in x, you're moving at least 1 in y. You have a valid move here. But that is only because you are on the white team. Now I'm thinking about this, we can't really do a mat absolute here. Let's just leave it on that because we're gonna need -1 if we are on the black team. So let's just leave it like that. If it's on 1 here, that's fine, we return true. Okay, so at this point we jump 2 tile in x, we also need to jump 2 tile in y as well. So let's check that. So if delta move y is equal to 2, since we're going up again, we're not going down. If we're going down, it would be -2, and that's only working for the black team. So you can't go in the other direction if you're on the white team. Unless you're a king, that's why we have this condition here. We'll also have it in the other statement where we cover the black team mechanic. Right, so if our delta move in y is also 2, let's grab the piece in the middle. And I'll do that using a, should we do a vector 2? No, that's kind of stupid. We're going to do piece, p, is equal to board, because we have a reference to the board. Remember, we get it in parameter here. Now to get the piece in the middle, what we'll do is we'll do a actual x1 plus x2 divided by 2, which is going to give us, the average in between the two, and the average is the middle piece in this case. Same thing for the other side, so y1 plus y2 divided by 2, and that should give us the piece. Well, at least if there is no piece, it's going to give you what is on top of the tile, in the middle of the destination and the start. So, well, if there is a piece, right? If p is not equal to null, then that's a good start. But we're not able to jump our own team. We're not able to kill our own team. So we have to check if the piece we're jumping. So if p that is white is not equal to is white in this case, which means if the piece we're jumping is not the same color as ours, then we're allowed to actually jump. So return true. And only then, if we're not able to meet all of those conditions, so if it's not a white, if it's not jumping 2 in x, if it's not jumping 2 in y, if the piece is null or the piece is not the same, is actually the same color, then we just keep on going here, and we'll have a return false at the very end. We can put it now, but basically that means it's not a valid move. Okay, so we've done for the white team. Now let's do it for the black team as well. The same exact thing. We won't do a else if statement here. We'll just do another if, because in case it is a king and it just doesn't meet a white move, it might meet the black move. So that is why I'm just going to leave the two as if statement and not actual else if. Okay, so we just have to swap things around here. Delta move, that's fine. I mean, that's an absolute, and it's going to work for both team. Now, if the delta move in y is equal to -1 in this case, then we return true. Let's have a look at the other one here. If delta move is -2, then we can enter this. Do we have to change anything in here? I don't think we do. I think that's really all we needed to change. And this is how we check if we have a valid move or not. That's that's really very simple here. Cool. So we can now go back to our actual checkerboard and try to make sense out of this. We have a selected piece, it's not out of bound. At this point, we check, is the move we're trying to do valid, right? So if selected piece valid move, and then we send our board, so that's pieces our x1, our x2, y1, oh sorry, x1, y1, x2, and y2 in that correct order. If we're able to do that, then well, we managed to actually do a move. So we should move, but before we do that, let's actually check if we have killed anything. So did we kill anything? If this is a jump, so we're gonna check, is this an actual jump? If matf.absolute again, x minus x2 is equal to 2. So if we killed something, let's grab the piece in the middle and let's actually get the piece in the middle and start its removing process at this point. So the piece in the middle, we just got it on this side here. We'll just grab the same exact call and put it here. So pieces p is equal to pieces at this very index here, and at this point we check, is that piece null again? We're just gonna make sure everything is fine. So if piece is not equal to null, then we're gonna set it to null. So pieces at this index, again the index in the middle, is equal to null, and then we'll remove that piece. So destroy p or something like that. And that is only if we manage to kill something. Okay, so that part is done. Now let's actually move the piece for real. And the way we're going to do this is we're going to set it in the array first. So pieces at the index x2 and y2 is now equal to selected piece. And then we're going to remove the old one. So pieces at index x1 and actually y1 is equal to null. We don't need to have anything in here anymore because we just move our piece, so it's no longer at the old position. And then let's finally move our piece with the move piece function. We're moving the selected piece and we're moving it at x2 and y2 just like that. And that's pretty much it. At this point, we'd like to actually swap the turn. I mean, we have a valid move. Let's just end the turn at this point. And this is a function we don't have just yet, so we'll just start writing it down slowly like we do. And let's just copy that over. Typing in here, private void, end turn. And we're just going to open up the brackets for now. We're not going to be coding too much inside of it because we want to test this out. Say we have this tile here. Trying to move on the right hand side. For some reason it sticks, and that's definitely not cool, but we have some kind of mechanic almost working here. It's definitely far from working, but if I just click and then I release here, that's fine. If I click and I release here, that doesn't work. I mean, my selected piece is still part of my selected piece is still part of what it was, and we're not dropping the selection, we're not moving our piece back to where it should be. We're just creating those weird placement here, and that's definitely not going to work out. So we'll have to find a way to actually fix this. So back in the end turn function here, we are going to just remove that selected piece. The selected piece is going to equal to null. We're pretty much done moving it. And also the start drag is also going to equal to null, or in this case vector 3.0. So what else do we need in here? We also need to swap the turn, but right now we don't really know which one, which turn it is. And we'll just put it as a boolean at the top for now, but eventually we'll use it more. Let's do a private bool is white turn, and in the start we always start with the white, so let's just do is equal to true. But that's only, you can be putting it up here as well, it doesn't really matter. It's always a white turn, and let's also check if the player, which color is the player, so is white. We're not really using these two right now because we want to test locally, and if you just end the turn for the white, then there's really no one to be playing the black part right now, so I'm not going to be using them too much until we put the actual multiplayer in. But we still have to do that in the end turn. In the end turn, we'll do is white turn is now equal to is not white turn. As simple as that. And we also have to do something else. So at the end of the turn, let's check for the victory status. So check victory. Another function we don't have that I'll simply just create up here. So private bool, check victory. And this one is going to take care of just ending the game, basically. And let's see where we are right now. So I click that, I drag, and it just perfectly goes at the right place. However, still have a lot of bugs here. Unable to move on the white tiles, which is perfectly fine. That's exactly what we want. We still have this little floating piece sometimes that it's not being moved back to where it should be. But if I just put this guy right here, if I just try this again actually, cleaner, and I just do like valid moves, this is supposed to be a valid move, doesn't seem to work here. This one is a valid move. Can we go backward? We can't seem to go backward, so that's very good. But it does go forward, and it doesn't go like, on the right side here. You're able to move on the white side perfectly fine, but however the black team doesn't seem to, seems to have an error right now. Oh, and I just remember why we have one of those errors here where one is able to move and the other one isn't really able to move. And it's because they don't really know which color they are right now. As you can tell in the prefab, we have the piece, but none of them is toggled as is white. So we just toggled it for the white piece. And I think now both sides are not going to work anymore. Yep. So I have to reverse those, but basically they should actually work if I just try this out really quickly. Now this one is white, this one isn't. Yeah, they seem to work a little bit better this way. However, the naming and the way my condition works are inverted, so we'll just go with the names here and we'll have to reverse it in the code instead. If we go back quickly to the pieces, in my valid move function here, we'll do y2 minus y1 instead. That's going to make a little bit more sense because we're taking the destination minus the start, and then we actually get the right value. So as you can tell now, it's a little bit more clever, it's a little bit more working. And let's actually try to take a piece. As you can tell, the move was valid, however we didn't really delete the piece and it's still there. Can we still use it? That's my question. Yes, we can still use it. So definitely a problem here, but at least we're able to do the jump, which is quite cool. Alright, so I'm going to end this for now, but we're going to come back, we're going to quit. Alright, so I'm going to end this for now, but we're going to come back, we're going to make everything clean, everything really feels good to play basically, so we're going to make everything really just neat, and then just implement the server, but we have to do this gameplay part first, guys. And please leave a like, leave comments if you enjoy, if you learned something. You can also check out the Patreon page to support me and support the channel, support the courses, the other tutorial, and more. Hopefully more is coming soon. And guys, I will see you in the next one.